So we finally made it to problem 18, which I feel like I've been hyping up for a while as being a long and difficult problem. And we're going to go ahead and take a look at it here on the Algebra 1 final review. And you're probably looking at this graph and thinking, ugh, what is going on here? And it's a little bit easier to see what's going on big ideas because the lines are color-coded. So it's a little bit more obvious what's happening. But I will still be able to puzzle this out. And what we need to do is we need to determine whether or not any of our lines are parallel and perpendicular. But in order to determine those lines, which might be parallel and perpendicular, what we need to do is we need to calculate the slope of all three lines and then compare them. So we need to first identify which slope goes with which line. And our lines are A, B, and C. So I'm going to set up my slope calculation for line A. Now, in case you've forgotten, to calculate slope, you use m is equal to y2 minus y1 divided by x2 minus x1. The x2, y2 and the x1, y1 refer to points on those lines. So we're first going to look for the slope of A, and A is this line right here that goes up and down. And we need to identify what the 2 points that are given. One of the points is 0. Wait, no. This point is -3, -1. So our first point is this one right here, -3, -1. So I'm going to go ahead and set this up. And my first point is going to be x1, y1. So the x part of it is -3. So we're going to have minus parenthesis, -3. And our y part is a -1. So we're going to have minus parenthesis, -1. So that was the first point. Our second point is this one down here at -5, -4. So our x of -5 goes on the bottom, and our y of -4 goes on top, as every point is x and then y. The reason I didn't put the -4 and the -5 in parentheses is because they don't need to be in parentheses because there's nothing sitting in front of them in these problems. But I put the second ones in parentheses to make it clear that the negative sign is part of the formula. And then the fact that these are negative numbers is also included. So we need to simplify this before actually finding our slope. Our -4 and -5 both just get to sit there, but -1, subtracting a negative is the same as adding. And likewise, -3 is +3. So that means we have a -4 plus 1, which will give us a -3. And -5 plus 3, which gives us -2, meaning the slope of line A is 3/2. So we ran into my formula written on the right side there a little bit, but our slope of line A is 3/2. And you can it's difficult to tell what the slope is just from looking at the graph because of how cluttered it is, but you can kind of see that from this point to this point, it's up 1, 2, 3 boxes and over 1, 2. So 3 is what we would expect it to be. So that's line A. Now, before we can tell if it's parallel or perpendicular to anything, we have to figure out what our other line slopes are. So we're going to calculate the slope of line B, and we're going to do it in the same way. So I'm going to put my subtraction signs in, and then we're going to find our points. So we're going to go ahead and make our first point for line, oh, this is actually not line, I'm looking at the wrong line. Line B is this one that goes across here. Line C is the other one that goes up and down. But line B goes across. So let's look at our point. Our first point, we have a little line connecting it to -6, -4. So I'm going to put that down here. My x is -6. My y is -4. Just like in the one above, it goes in parentheses. For the next point, we have -2, -6. So our x this time is -2. That goes on the bottom. And our y is -6, which goes on top. And once again, we got to simplify it by removing some of those negative signs. So we have -6 minus -4 is the same as adding 4. On the bottom, we have -2 minus -6. That's actually a +6. So -6 plus 4 is going to give us -2. And -2 plus 6 is going to give us +4, which reduces to -1/2. So that's the slope of line B. I was originally going to look at line C, but I caught it midway through. Now we need to look at line C, which is this one right here. It goes up and down. Looks pretty similar to line A, but we'll see what's going on. So we once again have to calculate our slope. And we're going to make this point down here of -3, -6 our first point. So we have our double negative on the top and the bottom. So our x value is going to be -3. So we have minus -3. And our y value is -6, minus -6. As for our second point, x is 0. And our y is -1. Now, let's simplify it again. -1 minus -6 is -1 plus 6. And 0 minus -3 is just a +3. -1 plus 6 is +5. So our slope is 5/3. So we have our three slopes, and now we need to determine if any of them are parallel and perpendicular. But to that end, we need to discuss what makes lines parallel and what makes line perpendicular. In order for lines to be parallel, they're supposed to have the same slope. So same slope equal parallel, which is going off the edge of the screen here. The same slope is parallel. Perpendicular lines are negative reciprocal slopes. Negative reciprocal. That's probably not very legible, but essentially what that means is if the first line has a slope a over b, the second one that is perpendicular to it has a slope -b over a, meaning that, for example, let's say 5 over 4, its negative reciprocal slope is -4 over 5. So the sign on it switches and the fraction flips over. So let's see if any of our lines have the same slope to see if they're parallel or if they have perpendicular slopes. So if we look at our three lines, we have 3/2, -1/2, and 5/3. None of those are the same. So we would say no lines are parallel. Now in Big Ideas, the word that's actually used in the drop-down menu is none, meaning none of the lines are parallel. And the reason for that, and the way it's described on Big Ideas, is the slopes are all different. If there were parallel lines, and you'd be able to select like A and B are parallel, or A and C, or B and C, or all of them are parallel, you would say the slopes are the same. Now, if we look at the perpendicular portion of this, we need to look to see if any of these fractions that we have here, 3/2, -1/2, and 5/3, are negative reciprocals of each other. And if we look at them, you're probably going to notice pretty quickly that none of them are negative reciprocals because none of the fractions look like reverses of each other. I mean, these both share a 3, but this is 3 over 2 and this is 5 over 3, and they're also not the right sign, so they're not perpendicular. And -1/2, well, -1/2 is not the flipped over version of 3 over 2, nor is it the flip over of 5 over 3, because if we flipped over -1/2, it would be -2. So it actually turns out that in this one, none of the lines are, that's the exact verbiage that's used by Big Ideas, none of the lines are perpendicular to each other. And the reason for that is because the slopes are not negative reciprocals. Because negative reciprocals are what we need for our lines to have the same, to be perpendicular. Now, if some of the lines had been perpendicular, we would have said like, you know, lines B and A are perpendicular to each other and the slopes are negative reciprocals. Or rather, actually the way they want you to do this is they want you to particularly say in the first box here, you would say line A is perpendicular to line B, for example, and the slopes are negative reciprocals, because negative reciprocals is what you need. But in this particular example, we had no parallel lines and no perpendicular lines. So it was a long problem and we ended up coming up empty, but that's the reason why we went through all the steps. Don't just look at the graph and say, well, they look like they're parallel or they look like they're perpendicular, because in this one, it does kind of look like lines A and C are perpendicular to B and A and C are also parallel to each other, but that was because we were being deliberately misled, I guess, by the problem maker. So watch out for that. In our last video, we'll look at problems 19 and 20, which deal with parabolas.